So it's time for the next big topic in physics, and it's a popular one: astronomy and cosmology. Now, this gets a bit of a look in pre-university physics, not as much as people would usually like. As I say, it's a very popular subject. It might get a chapter or two in your standard textbook nowadays, so I'll probably cover quite a lot more than that in this series of videos. Astronomy is popular. It's easy to get involved in. You've got amateur astronomers, can be pretty much of any age. Anyone can go out and observe the night sky. Telescopes and binoculars are more available than they ever have been. And it's also got the advantage of being less abstract than a lot of the other topics in physics. We can easily visualize a star, a galaxy, a planet, and such like. And that makes it so much easier to understand the theories and descriptions that surround those objects. We don't have the same luxury quite often in other topics in physics, things like electricity and magnetism, much more mathematical, much more abstract. So astronomy has got a lot to be said for it as a popular topic, just because it's so much more accessible and easy to understand. So what is it that we're actually going to be covering in this, and what is the difference between astronomy and cosmology? Well, let's kick off with astronomy then. I mean, this is one of the most ancient of sciences. From the dawn of time, as soon as people knew what they have consciousness, they'd be looking at the night sky and thinking about what it is they're actually looking at. The sun, the moon, the stars, they've always been there. So it is the most ancient of all of the sciences. It's really about the study of those individual objects. So we're looking at things like stars and galaxies and planets and these things, very definite objects, and we want to describe what they're made of, how they're formed, how they evolve, that sort of thing. So it's description of those individual objects. Now, in the standard A-level syllabus, you'll be looking mainly at stellar evolution, so how stars evolve, how they're classified. So that's the main part of it. You get some other bits that we look at, things like Kepler's laws, which will describe the motion of planets, but tend not to say all that much about the individual planets themselves. So I'll include a lot more information about those. And other related things, other objects in the solar system, asteroids, comets, and then things outside of the solar system. So nebulae, planetary nebulae, and globular clusters, those sort of things, and then get into a larger scale of looking at galaxies and beyond that. We're very much looking at those individual objects. And as I mentioned, I mean, this is something where amateurs really get involved in this, and they can make serious contributions to astronomy because there are a lot of objects. The universe is big. Telescopes that amateurs have nowadays have got serious power, a lot of light gathering capacity to them. So amateurs can make very sophisticated observations of these objects, and there are so many objects. Professional astronomers can't keep track of all of them, and there are a lot of interesting events, what they call transient events, so short-lived events that happen on these objects. It might be an asteroid colliding with, I don't know, Jupiter or something like that, and causing a little bright spot on an observation of Jupiter. It might be a supernova that appears. I mean, you think how many stars there are. People can't keep tabs on all of them just in the huge professional observatories. So amateur astronomers will quite often be the ones who first notice these things. If there is a supernova or some event, if a new comet has appeared, these sort of things, amateur astronomers can really contribute to. Right, so that is astronomy. Cosmology is nowhere near as ancient, at least how we're talking about it here, as astronomy. So cosmology, really, we're talking about anything, any study here. So we've got an ology of the cosmos. So some description, understanding of the universe. Now, this has taken many forms over, the history of mankind. you're going to have religious cosmologies. They're going to be the earliest ones that we come up with. Obviously, that's not what we're interested in here. We're interested in scientific cosmologies. We're talking about the origin and the evolution of the universe. And from a scientific point of view, that is not anywhere near as ancient as astronomy. It came much later on, and cosmology as we know it now really kicked off during what's known as the Great Debate, in inverted commas, which was in around about 1920, so only about 100 years ago. This is how recent it was that people started thinking that there were objects outside of the Milky Way, outside of our galaxy. Prior to that, you go back before World War One, and the general opinion was that the universe, the cosmos, was our galaxy, and everything was inside that. So, okay, there would have been a cosmology. That is going to be part of what the cosmology was, describing the universe as they thought of it back then. It was just our galaxy. But there weren't that many scientific observations around that. As we know now, that's a long way from the actual reality of what's going on. I mean, we have a lot of questions with our current cosmology, but we know it ain't that. So it's relatively recent, the sort of cosmology that we're talking about nowadays. I mean, this is where we're talking about things like the Big Bang. This is a modern theory. This has come in the last century. So anything to do with the Big Bang, the cosmic microwave background, the formation of different chemical elements, all of that stuff is part of cosmology. And you can see how that's detached from these individual objects that we're going to study in astronomy. The Big Bang, that's the origin of the universe itself. The cosmic microwave background, that's at a universe level, is at a cosmos level. The formation of the elements, again, that's something. How was that happening inside the evolution of the universe? We're not talking about the formation of elements, say, in the evolution of a star. That would be a separate thing. When did we first start getting helium in the universe? When did we start getting heavier elements than that in the universe? So there's a broader sort of step back view when we go to cosmology, taking that step back, looking at the universe as a whole. So I'm going to be adding in again a bit of extra information that goes beyond the limited amount that's covered in pre-university textbooks. So, of course, we'll look at the Big Bang. That's usually covered, but I'll put in more about the cosmic microwave background. I'll put in more about dark matter, dark energy, and the expansion of the universe, how that seems to be accelerating. And we'll do that alongside the things like Hubble's law and cosmological principle and such like that gets covered anyway. A really interesting topic, this one, that people really do enjoy. So there's going to be a lot more description in this, a lot of descriptive videos, less maths. And I mean, that has pros and cons, because a lot of people don't like doing the descriptive exam questions. So there's going to be a lot of those, of writing through how stars evolve and such like when we get onto the practice questions. But yeah, this is going to be a lot of fun, I think, going through this. I find all of the topics fun, but this one will probably be one of the more popular ones, I'd imagine.